Hi guys, welcome to the first lesson in our Unit 3, which is in Chapter 4. And we're going to talk about solving systems of equations. So again, this is nothing new. So the first kind of situation that you have when you're solving systems of equations is probably the most obvious one. So it's when two lines go together and your answer is right there, and it's always a coordinate point. So your solution is going to be a coordinate point. Okay, so this is called independent because these can move, each of these lines can move, but as long as they're meeting in that same spot, it's not going to affect your solution. Okay, the second type is when you have a pair of parallel lines and your solution is, you're not going to have one, so it's going to be no solution. And in a situation like this, you might come up algebraically with something like this. 7 equals 5. So 7 does not equal 5. So if it doesn't make sense, you're dealing with two parallel lines. And in this case, it kind of makes sense. It's inconsistent because it doesn't make sense, so there's no solution there. And the last one, it's just going to look like one line, and it's going to ask you to okay, well, solve it, and you're going to question whether this is the right problem. But your solution is going to be the set of all reals. So it's going to be a true statement. So this is like 7 equals 5 over here. You might get 7 equals 7. Okay, so when you actually put your answer, you're going to say infinitely many solutions because anything will work there. Also, as we go on, you're going to actually find the equation of that line as part of your answer. And this is also dependent because the two lines are not on top of each other. So if one line moves, the other line has to move. So those are the three categories of solving systems. So let's go ahead and start with what we know. So we are going to solve the system by graphing. So I want you to graph this line and then see where they meet. Okay, so I did my two lines in different colors and notice they meet up right here at 1, 1. So no matter what type of solving we do, whether graphing, substitution, elimination, we would end up with the same answer every time. Okay, so go ahead and do this one. Notice that this is in that point slope form and this one's in standard form. So this is a downside about graphing is they meet somewhere in the middle. I can kind of guess like it's between 2 and 3 for my x and 2 and 3 for my y, but I can't come up with the exact solution here. So this is where graphing just doesn't really work that well for everything. So we're going to try this. We're going to try another problem using substitution. So what substitution says is just look for the easiest variable to solve for. So see that y is by itself. I'm going to solve this equation for y. So I have y equals 3x minus 2. And what I'm going to do is I'm going to take that 3x minus 2 and I'm going to substitute it in place of the y in the other equation. I have 4x plus 2 times y, which is 3x minus 2, equals 6. Go ahead and solve for that and see what you get. Okay, so you should have gotten x equals 1, and this problem should be starting to look familiar now because it was that very first one that we did. So once you have 1, you're going to plug it in for x there. So 3 times 1 minus 2 is 1. So my solution, just like we found in that first problem, is 1, 1. And I don't have to do any graphing then. Okay, so this one solved by substitution. So this one, you're just going to have to choose one variable to solve for. So it can be the x, it can be the y. So go ahead and do that. So in this case, I took the first one and I solved for y, and then I plugged it in for y here, and I ended up getting x equals 14 over 13. So what I'm going to do is I'm going to plug it in here and get my y value. So I showed my work here, and I ended up with 14 over 13 for x and 4 over 13 for y. Now we're going to hit some word problems. Notice all of these word problems should not be new to you. So we looked at them, how to solve them one way in Unit 1, and now we're going to look on, see about having to solve them using systems of equations. I think systems of equations are a little bit easier, but it's just whatever you think. So I'm going to call cashews C and peanuts P. And so I want you to come up with two equations after you read the word problem. Okay, so the first one that I want to look at is this one. So C is going to be our number of pounds for cashews, and P is going to be our number of pounds for peanuts. So 275 times the number of pounds, and then $3 times the number of pounds of peanuts. And then we have this mixture here, just like we talked about in Unit 1. So it's going to be 290 for that mixture. So I want you to think about substitution. So I can take this 200 and I can substitute it in for this, and then solve if I need to. So go ahead and do that. Just see what you come up with. So after I did my work, I found that P equals 120. I also went through and I solved for C and plugged it in here. So I got P equals 120. So I know that the number of pounds of peanuts sold is 120. And I know that each type adds up to 200. So 120 pounds of peanuts, and 80 pounds of cashews. Okay, for this next one, I have 5% milk, and I have 1% milk, 2% milk. So this is how I see it set up. I know that X plus 90 gallons is going to give me some other gallon. So X is that 5%, the gallons of 5% milk, and then Y is that mixture. So I also know that I multiply these together. I get that. And so I think from here, I'm going to take this and plug it in for Y. Right here. So let me go ahead and do that work and solve for X. Okay, so in this case, it asks me how many gallons of the 5% milk, so I'm looking for that X. And so I'm just going to say 30 gallons. Okay, this one, if you'll remember, we didn't do it in Unit 1 because I said it's really good for systems of equations. So we're going to go ahead and try this right now. So I'm going to set it up for you just to kind of show you where my thought process is on these. Okay, so if you're going downstream, it's going to feel really easy to paddle because you got the current with you. When you're going upstream, you're working against that current, so you're really pushing hard. So that's why the time is slower. So I'm going to take this whole thing and times 3. I'm going to take this whole thing and multiply that times 27, and I have 6 times R minus C equals 27. And so if I divide this by 3, I have R plus C equals 9. If I divide this by 6, then I don't want to do that yet because that's going to give me the yucky answer. I think what I want to do is go ahead and distribute the 6. That would be the easiest. And then I could come over here and maybe just solve for R. So if I solve for R, I'm going to take that and plug it in right there. So I have 6 times 9 minus C. 6C equals 27. So I have 54 minus 6C minus 6C equals 27. So I'm going to subtract 54, and I get 12C equals 97. 5 by 12. And I get C equals 9 fourths or 2.25. So that's that current. So find the rate of the boat and still water and the rate of the current. So I know that the current is 2.25. So it doesn't matter. So I'm just going to take 9 minus 2.25. and I get 6.75. So this is the rate in still water, and the 2.25 is the current. Okay, guys, we are, I believe, done. Yes, we are done with this.